Welcome back, everyone, for the next part of the presentation, next part of the conference, where we are going to talk about development of waste to energy technologies projects in India. And for that, we have amazing lineup of speakers. We have Mr. Harshit Agarwal, who's a Deputy Country Sales Manager for Axens India Private Limited. We have Leif Vebenstad directly joining us from Norway. He is the chairman of Johnson's Chemicals, and we have Dr. Ila Tiwari, who is an AGM Environment SMS Envocare, directly joining us from Nagpur. So to start with the session, I would request Harshit to start sharing his screen, and then we will move forward with other lineup of speakers, and we'll invite them one-on-one by stage.
Thank you, Akshay. So, good evening, everyone. Good evening to the panelists, to the fellow speakers and presenters. First of all, I would like to thank the organizers for organizing this event. I will also begin by saying that I hope you and your families are safe in these unprecedented times. I also take this opportunity to say a few words about Axens. I'll not be too elaborate, I'll be quick. And I'll just want to show here that what we really do for those who are not aware about Axens. So, Axens is I'm sure some of you might know, Axens is a French company and we are quite active in 5 areas. On the right side of the slide, you see oil and gas is one of our main areas, petrochemicals. When gases is another one where we do the gas treatment. Then alternative and renewables, which we'll look at today, and then water treatment technologies. In these 5 areas, we provide technologies as a licensor. We also give products like catalysts, adsorbents, and proprietary equipments. Also, we support these markets with services like technical assistance, consulting, and training. Axens, as I said, is a French company, and it's a subsidiary of institution known as IFP, which is French Institute of Petroleum, which is one of the most prominent R&D institute in the area of oil and gas, petrochemicals, biofuels, and carbon capture solutions. Beside this, IFP has already had a long cooperation with its Indian counterparts. And for Axens, Axens has been established in India for many years now. It has been decades. And we are providing solution and services to all major companies in India like IOCL, BPCL, Reliance, ONGC. So we are very well established. And furthermore, we have shown some key numbers on the slides on the left side, just to highlight the Axens credentials in these areas. So, moving on, in the earlier discussion that we had today, we looked at policy aspects, market challenges that are involved in the area of utilization of waste, primarily biomass. So, just to take that discussion forward, I will talk about different technologies that are available in the market or different pathways that with which you can utilize bio residues as feedstock, both in liquid and solid form, to produce liquid biofuels, by utilizing these feedstocks. Now, we all know that in next decades or so, will be facing, or especially India will be facing, growing demand for the mobility. That is one challenge on one hand, and then definitely global warming on the other hand. So keeping these challenges in mind, our eminent speaker in the earlier discussion highlighted that India is poised to reach third largest consumer of fuels in the next coming decades, and then need to address these challenges, which I just mentioned a couple of minutes back. The government of India plans to increase the biofuel production by 2030. At the same time, there has been a strict target to reduce the greenhouse emissions up by around 30% in next 10 years or so. So some agencies have actually worked on in this area and highlighted that only a energy mix that combines fossil fuel with renewable fuels will able to meet this demand in next couple of years, or let's say next decade to come. If we look at different scenarios that are projected here in the slide, Even most conservative scenario, as you can see here, that shows that renewable fuel will play a vital role, not just in achieving the energy demands of this country, at the same time reducing the overall greenhouse emission that you normally have with fossil fuel based pathways. I mean, numerically, it's look quite encouraging. However, there are a number of challenges which some of eminent speaker in the earlier discussions highlighted that cost effectiveness is one of them, feedstock availability, flexibility are the other ones, and many more. I mean, to achieve these goals, definitely it would be required to have an approach or a pathway which is innovative, cost effective, as well as sustainable. I mean, if you remember during the last session, Mr. Das actually highlighted how important the sustainability is for such pathways. So keeping these goals in mind, Axens have developed and expanded its bio portfolio over last decades or so to provide a sustainable solution. I mean, it's important to have a solution which is sustainable. Now, this is a quick snapshot of Axens bio portfolio, where in the next 30 minutes or so, we will look at different pathways to utilize different feedstock, whether they are solid like biomass or liquids like used cooking oils or tar oil or residue from food industry or fish industry. Now, if we begin from the top, well, we have two processes which produces renewable diesel and aviation fuel, which we call as sustainable aviation fuel. First of them is vegan. This is a more traditional route. This is hydrotreatment of lipid feedstock into diesels and jet fuel, which is this method is quite well known in oil and gas industry. The second approach is fuel project, including gasel. This is actually a thermochemical conversion of lignocellulosic biomass into liquid fuels like diesel, jet fuel, and some naphtha. Now, this utilizes gasification and Fischer-Tropsch units to carry out this conversion. Now, third process that we'll look at today, and some of the speaker already highlighted during the day discussion, is lignocellulosic mass conversion into cellulosic ethanol through enzyme route, which is actually a biochemical conversion. We call this process as Futurol. Now, these three pathways will look more in detail. Now, other processes are also there, but we'll not go into the details for that. So first of the, I mean, just for your information, as you can see bottom half of the slide, the first process is ethanol. This is, as the name suggests, it's alcohol to olefins. It uses a dehydration route, which converts ethanol into ethylene. Now, it is also possible to convert this ethanol and synthesize butadiene, thanks to Bio Butterfly project. This is not commercialized yet, but it will come in the market in next couple of years or so. Last but not least, BioTCAT project. I mean, this is a catalytic pyrolysis conversion of lignocellulosic biomass into aromatics, mainly paraxylene. And it is quite unique process because one of the topics that we heard during earlier discussion was stability of pyrolysis oil is quite a challenge. So this process actually addresses that issue, and it produces a sustainable fuel which can be further then upgraded into the products you like. So this is a quick snapshot of the portfolio that Axens have. Now quickly look at the vegan process. So moving on, I mean, the first process is vegan. I'm sure you must have heard a lot about biodiesel. Well, biodiesel is traditionally produced through trans-esterification route, where you have ethanol or methanol as one of the reactant to produce esters. Traditionally, the challenge there has been that it contains oxygen in it, so it leads to some challenges related to storage, transportation, which leads to a limitation related to its blending into the gasoline, or I mean, not gasoline, but the diesel that you have. This is due to the gum formation. Now, this is a big challenge because then what it means is you cannot blend this diesel more than 5 or 10 or 15% or 20%. There is a limitation to it. And that is why this other route is gaining more prominence, especially in Europe and US, where a lot of refineries are switching from fossil fuel based pathways to biorefinery. And this is one of the pathways which is quite proven, already commercialized, and very well known in the market. So there is a lot of know-how available. What it really does is uh, lipid feedstock actually undergoes hydrotreatment to produce renewable diesels like HVO, which is also known as hydrogenated vegetable oil. Now, some of the quick advantages I would like to mention here is, well, it is oxygen free. These are C16 to C18 paraffins. So very similar molecule in terms of traditional diesel molecule. Then higher energy density because you are adding hydrogen into the process. And it has a tunable cold flow properties. I think cold flow properties is quite important when we talk about commercial scale fuels, whether it is summer, winter, or Arctic diesel. So traditionally in biodiesel, you need to add some additives, but in this process, even just by changing the operating condition, you have a finished product with required cold flow properties. Finally, I'll not go into each of them. Finally, I just want to say that higher cetane number is something that is quite useful here because it brings a lot of value when you are blending it into a diesel pool that you already have. So it's a very superior property that you get here. Now, quickly look at how that translate into chemistry and scheme of things. I'll not go into details, but I'll just want to highlight here is how we have made this approach cost effective or economically feasible, because that is something quite important for these pathways. So what we are doing here is we are targeting a rupture or fission of CO bond rather than CC bond. This CO rupture or fission is known as deoxygenation over decarboxylation if we break bond here. The advantage you get here is you will have higher yield of diesel or jet fuel, which means you will able to improve your OPEX and reduce your CAPEX. At the same time, consuming similar kind of hydrogen in both the approaches. Now, how that translate into scheme of things, you have a pre-treated renewable oil or lipid feedstock like used cooking oil. You hydrotreat it in a hydrotreating reactor, then you have a hydrotreated oil. Now, because the melting point of this oil is more than 20 degrees Celsius, so which doesn't fit into specification you need for aviation fuel or diesel, so you have to upgrade it further, and you do it through hydroisomerization. Well, again, as you can see, there are two approaches to it. One is hydrocracking and another one is isomerization. We have chosen isomerization because it produces less yield of gases, and that means you can maximize your yield for main product. So this way, again, it improves your OPEX and reduces your CAPEX. Eventually, you get a product which is ready to use. It doesn't need any post treatment. You can straight away use in the existing setup. So it's a drop-in fuel. Now, quickly look at the properties. With vegan, you can easily achieve any kind of cold flow property, whether it is summer diesel, winter diesel, or aviation fuel. Uh, you can achieve all the temperatures for the cold flow CFPP that you want. While you do that, definitely it will have an impact on the yield because you are going towards more severe conditions. So your yield of the light component will slightly go up. Then another important advantage you get here is very high cetane index, which is quite essential when you talk about diesel because typical cetane index is around 50 for a commercial diesel. Here you are getting 75 or 70, which is a very premium property. Last not the least, specific gravity is something that needs to be considered when we are thinking about 100% use of HVO. On the right side, it's just a pictorial view on how the feedstock looks like and how is the end product looks like. So this is just for quick realization. Now, this is a quite important slide because this process is quite versatile in nature. What it means is you can use multiple kind of feedstock, different kind of feedstock available throughout the year, and to produce different products, diesel or gases or maybe jet fuel. So it gives you a lot of flexibility. Even capacity flexibility is there, so you can pick and choose what your capacity you want based on the feedstock availability that you have. So it is a quite flexible and versatile process. In terms of our experience, one of our commercial reference is at Total Lamed Biorefinery. This is, I don't know if you know it, it's in France. The important thing to note here is this is the only refinery, as per the press release by Total, this is the only refinery which made profit for them during the lockdown period. So this tells you how this bio route can bring a lot of revenue for you. But at the same time, we had to consider that in Europe and US, they have a lot of incentives when they adopt such a route. Some of our other references are in Poland and very recent in Repsol in Spain. So as I said in the beginning, this process is quite proven, quite well known. Only thing is some modification needs to be required. So you can use it in existing setup. You can also consider co-processing, or you can put up a grassroots plant for this particular process. Now, quickly moving on to the other process to produce renewable diesel and jet fuel, which is biofuel project, including Gesell. Now, I'm sure this is more relevant to fuel. It's a complete value chain from biomass conversion to liquid fuels. So what it means is it involves pretreatment, gasification, syngas purification, Fischer-Tropsch synthesis, and then upgradation of the waxes that you get from Fischer-Tropsch. Again, it's a very versatile process. When I say that, I really mean it, because here you can use biomass. We are also exploring and testing the technology with waste feedstock. Coal can and pet coke can easily be used. At the same time, you can, if you have a choice, you can also use natural gas. Then you generate a syngas, and which produces various kind of feedstock, diesel, various kind of products like diesel, aviation fuel, and naphtha that goes into petrochemical feedstock. So it's again a very versatile project that we are talking about. And in a nutshell, what biofuel really means is, it's you can see how extensive and massive this project is, because we are talking about more than 180 million euros of investment program for this project. Already more than 10 years of R&D effort has gone in development for this project. We are using a partnership model. It's a consortium which is known as BioNext, and a partnership model in this area is quite common, where a lot of partners come in and bring their expertise to develop a process. So we have utilized the same, and biofuel is one of the end product for the same. Now, one of the important thing here is, if you see, we have a two demo plants. I mean, one demo plant is for the torrefaction section, which is, in vague term, you can say the pre-treatment of biomass before gasifier. That is in Vanet in France. Another one is in Dunkirk, which is downstream of torrefaction. So the purpose of two demo plants, or actually three demo plants, there is another one for the Fischer-Tropsch section. These three demo plants are there to validate the technical and economical feasibility of this project. And through these three demo plants, we were able to, the results are really good, and we were able to validate the results. And maybe in the coming times, you will see the commercial aspect of this technology as well. I mean, how that translate into scheme of things. You have a biomass, you torrefy it, which is more like a mechanical drying. I mean, what the intent here is, you have to reduce the moisture up to a certain level. Then you have a pre-torrefied biomass, which looks more like a coffee powder. I mean, just to imagine, it's a vague term. Then you take it to oxygen-fired gasifier. You produce a syngas. In the syngas, the next aim is to balance out hydrogen to CO ratio that you do through acid gas removal and final purification through catalysis or adsorbents. Then you take it to Fischer-Tropsch reactor, where you produces wax to produce end fuels like diesel and jet fuel or naphtha. So this is the scheme, typical scheme. I'm sure you must be wondering then what GESEL is, because we have just spoken about, I just spoken about fuel. GESEL is actually the Fischer-Tropsch section. This covers purification of syngas, the Fischer-Tropsch reactor, and the upgradation of wax that you produce in the Fischer-Tropsch reactor. Again, it was developed, this GESEL part of it was developed in consortium with ENI. Now, how that translates into scheme of things? Well, this GESEL actually utilizes a low temperature regime, which helps you to maximize the wax yields. It's important to have wax because here we are targeting diesel and aviation fuel, most of it. And in case you want to target naphtha, that is also possible. And that can be adjusted through this hydroprocessing step, where you can mix and match based on what you really want to have as a product. Now, in terms of its properties, I mean, just to summarize the product that you'll get, the products are fit to use. I mean, drop-in quality straight away. You can use in the existing setup. No, they have no contaminants, no sulfur, no aromatics. Quite paraffinic in nature when I talk about diesel and kerosene, and meets all the required specifications that are there for these fuels. At the same time, these being premium fuel, that's one advantage. Another advantage is it reduces greenhouse emission up to 80 to 85% based on what is the source of your hydrogen. That also go on whether it is renewable hydrogen or blue or gray hydrogen. So that varies between 60 to 85%. Now, in terms of our experience, well, as I said in the beginning, we have 3 demo plants. On the left, you see a demo facility in France, Venet, and on the right side, it's a downstream of torrefaction. This is a complete chain from gasification to fuel generation. Now, only thing to highlight here is you must be wondering then why we have set up a different torrefaction plant at a different site. The reason was we wanted to decentralize the whole system because to transport a biomass is quite expensive. So there is a flexibility that you can take this torrefaction unit to the site where you are extracting this biomass, torrefy it and convert that into powder. And you can then transport that powder to the conversion site, which is quite economical to transport, right? And this torrefied biomass is, I mean, can be exposed to harsh condition and can bear all the, I mean, like rain conditions like rain or wind or anything. So that's not a problem. Another, I mean, third demo plant is for GESEL, that is in Italy, Sannizzaro. It has been operating since 2007 or 8. So this is just for the Fischer-Tropsch section. These are some picture of our site just to show you how extensive the project is. It's not a small pilot scale plant. It's a very big demo facility with all the section at a commercial scale. This is about the fuel project, including GESEL. I mean, I just forgot to say that, again, it's a very extensive and massive project. And a lot of research have already gone in to develop this project. Now, next or maybe last not the least, the last process I want to show here is Futurol, which is biochemical conversion of biomass into cellulosic ethanol. Again, here the intent to show you is the latest updates about this process, because I'm sure a lot of you must have heard about it. I just wanted to show you that, again, it's a very extensive project. I mean, we are talking about 90 million euros of investment just for the project, more than 10 years of R&D program, more than 12 R&D centers throughout Europe, as well as many partners. I mean, you can hear it's again a consortium. Again, we have utilized the partnership model to bring different expertise together to develop this process. And if I tell you in terms of timeline, it's quite long. In 2008, this consortium was built. In 2011, the pilot plant is operating since 2011. And 2015, our demo plants are operating. And in 2017, this process was commercialized to fit to use. Now, I'll not go into the chemistry, but I'll again highlight here is the steps we have taken to make the whole process economical. Because you have to look at, I mean, no process, when we look at different pathways, no process is good or bad. It's about how much you can spend, right? And what kind of feedstock quality you have. Every process has its pros and cons. So here we have tried to we have taken a lot of steps to make the process cost effective and to improve its economical feasibility. The first treatment step is, the first step is pre-treatment. The what we have done is, through operating conditions, right operating conditions, we are able to extract maximum C5 sugars from hemicellulose. I mean, what it translates into is, then you can have a very high or maximum yield possible for the ethanol. At the same time, the cellulose structure is not disintegrated. The cellulose is fit there, which is later hydrolyzed in the third step. So this way we are able to maximize the yield of ethanol. The next step is co-production of enzyme within site. So we are producing enzyme at site. This is just for the economical reason. This actually reduces the operating expenses or production cost up to 15 or 20%. It's a big reduction when you do co-production of enzyme at site. The third one, which is quite a major step, is, or this step is also very well known. This is hydrolysis and fermentation step. What we have done here is, we are doing both hydrolysis and fermentation in single reactor. This means is, you reduces the number of reactor, hence reduce the capex. This reduces the overall enzyme requirement, because the enzyme is a microorganism. So in same environment, the same enzyme can adapt very quickly to both the tasks that it has to perform. And what it means is, when you have a very flexible, very active enzyme, then you can achieve a very high C5C6 sugar conversion into ethanol, and hence very high yield, or maximum possible yield, if I must say. The next step is quite standard. It is just purification of the ethanol that you have up to a fuel grade or food grade quality. This is done. The main thing we have adopted here is, we have bring in innovative heat exchange methods to improve, to reduce the utility consumption. Again, this is a very flexible process. You can use grassy residue, you can use straws, you can use woody biomass, as well as energy crop. I mean, you can use everything here, and it gives you a very consistent performance. Again, this is the same slide as I discussed in the beginning, that we are doing a co-production of enzyme. This actually reduces up to 15% of the production cost on an annual basis. Now, quickly look at our experience in this area. Well, as I said in the beginning, the pilot plant is operating since 2011. The size is 1 dry ton per day. It's from biomass to ethanol, so it's a complete chain. I'm on the right side. It's quite interesting. You must be wondering, then, if we have a pilot plant, why we have set up two demo separate plants for biomass pre-treatment and enzyme production. The reason was, during the initial phase of the research, we realized that for better economical feasibility of this process, it's very important to validate these two steps at an commercial or industrial scale. And that is why you can see the pre-treatment process is very big. I mean, we are talking about 100 dry tons per day of biomass of pre-treatment, and 100 meter cube of liquid volume for enzyme production. I can confidently say that these are some of the biggest demo plants that you will see for this process in the world. And this has really helped us to make the process cost competitive and economically viable and sustainable. Now, in terms of our experience, well, last year we sold a plant to INA. This is one of our references. It's a quite significant capacity plant, 55,000 tons per day of cellulosic ethanol. I mean, per annum of cellulosic ethanol, utilizing various kind of feedstock, agricultural and energy crops. So this is it. That brings me to the end of this presentation. Well, I'll finish here by summarizing that what I have just said. That is, in today's time of energy transition, industries are exploring different pathways. I mean, what we foresee is the in the short span of time, it will be a combination of pathways. You know, it will not just be ethanol, it just not be diesel, it will be in conjugation with the renewable hydrogen, ammonia. All these processes will combine together, and this will help us in meeting our future energy demands. At the same time, it will help us in reducing the overall emissions or reducing the carbon footprint. I mean, which would also require encouragement from policy perspective, definitely, because these policies are already there in US and Europe, and this kind of policy support definitely will help us in spearheading such technologies into the market. Then innovation is another thing that will really need in this area, along with flexibility of the process as well as investment. And that is where Axens is here to provide you the complete set of technological solution in the form of Futurol vegan and bio tea fuel to achieve a sustainable transportation system as well as sustainable chemical growth. So that is it from my side. I'll be happy to take your questions in the next minutes or so. Thank you.
Thank you, Harshit. Thank you for the presentation and letting us know the services and the offerings from Axens India. And before we take questions, we move forward to the next presentation, which is from Leif Vebenstad, who's the chairman for Johnson's Chemicals. And we are going to present this over a video that Leif has shared with us. And here we are going to start with the next presentation from Leif Vebenstad, who's the chairman for Johnson's Chemicals.
Hello, my name is Leif Vebenstad. I'm chairman of Johnsen Chemicals in Norway. We have worked with mechanical and chemical cleaning of combustion since 1965. As some of you know, Norway is big in oil and gas, and we used to work with combustion catalysts for oil products. But when combustion catalysts became standard in all petrol and diesel, we developed a combustion catalyst for solid fuel like waste, biomass, and coal. From a complete combustion, you will find an emission of carbon dioxide and water. If you have any other emission, you have an incomplete combustion. Instead of cleaning the emission from an incomplete combustion, we improve the combustion process and reduce the creation of emission. We have developed a combustion catalyst for solid fuel. The active ingredients we use is a manganese complex. The product is environmental friendly, it's liquid, and the normal dosage is 1 liter per ton. The safety data sheet has defined the product as irritating. As we see here, we increase the efficiency of the fuel. If you have a complete combustion with no emission of carbon monoxide, there is no room for improvement. But if you have an incomplete combustion with emission of carbon monoxide, there is room for improvement. The manganese complex is an oxygen scavenger that attracts all available oxygen to the surface of the fuel. All available oxygen is utilized in this improved combustion process. So we create carbon dioxide instead of carbon monoxide. This will again then reduce the level of oxygen in the boiler. The reduced level of oxygen reduces the creation of sulfur dioxide, as there is not enough oxygen available to react with the sulfur. We also reduce the creation of NOx, as there is less oxygen available for oxidation. We also use some ammonia to convert NOx to nitrogen. Particles is reduced as unburned carbon in the fly ash is reduced due to improved combustion process. Sediments are also reduced as unburned carbon is the glue that makes the sediment stick on your heat exchanger. And unburned carbon will be utilized in the improved combustion process. And this is important because sediments is a very good insulator. If you have 1 millimeter of sediments on your heat exchanger, you lose 8% in heat transfer. And if you have 3.2 millimeter of sediments, you lose 20% in the heat transfer. And that is energy lost forever. Reduced level of sulfur dioxide and hydrocyanuric acid will reduce corrosion in your boiler. In addition, we use an amine to create a protective surface inside the boiler and the tubing. Reduced sediments and reduced corrosion will increase the time between each shutdown for maintenance. This is a picture from application in Poland. We spray the combustion catalyst on the fuel on the conveyor belt before it goes into the boiler. The cost of this installation was less than $1,000. Here you see a picture of the temperature in the boiler seen from above. And you see that the center temperature of the boiler do not increase, but the temperature on the side of the boiler will increase as we improve the combustion process where it is incomplete. Here is 2 pictures I took for fun from a boiler in Poland. It's the same inspection hatch with 1 hour difference, and you can optically see the difference after 1 hour. Now I have an example from waste to energy in Norway. This here is Sarpsborg Energy. It was built in 2009. They have 2 Energos boilers that burn 5 tons of waste per hour. And they deliver 60 tons of steam at 22 bar and 220 degrees Celsius. We used combustion catalyst 1 boiler and left the other one as a reference boiler. The left picture is the reference boiler, while the right picture is our boiler. Sorry for the language, it is in Norwegian. But you see that the right column, all the way to the right on each picture, is the average, the latest 24 hours. And you see that after 3 weeks, we have a 58% reduction of NOx to 15.3 milligram per cubic. We had a 67% reduction of sulfur dioxide to 2.8 milligram per cubic, and an 84% reduction in carbon monoxide to 0.5 milligram per cubic. These are the same power plant where you show the emission over time. Left picture is the reference boiler, while the right picture is our boiler. The red line is NOx, the green line is sulfur dioxide, The blue line is carbon monoxide. And you see all the way on the end of our boiler, we had a short stop in dosing, and the emission came up again. Summary for waste to energy from this trial. We found that the carbon monoxide was reduced by 84%, the nitrous oxide was reduced by 58%, and the sulfur dioxide was reduced by 67%. As sulfur will never disappear, we found that the sulfur content in the bottom ash was increased by 16%. We saw that the fuel efficiency increased, and we saw that after this trial there was a scheduled maintenance of the boilers. With the reference boiler, they had to send in people with compressed air hammer to reduce the remove the sedimentation, while in our boiler, all the sedimentation had let go of the wall and was lying on the bottom. I will also show you some example from biomass. Here is from a furniture factory in Germany with a focus on emission, and they found a 60% reduction of carbon monoxide, 55% reduction of sulfur dioxide, and 50% reduction of particle matter. All the results here are from a TÜV report. We had a fuel efficiency on biomass. It's a university report from Opole in Poland on a boiler burning pellets. So that the fuel consumption was reduced by 30%. Also an example from coal. This is an old power plant in Poland, and what you see here is a very good example of how our chemicals work. You see that the emission of carbon monoxide was reduced by 33%, while the emission of carbon dioxide increased by 15%. That's 15% increased heat release. And as carbon dioxide has the double amount of oxygen as carbon monoxide, we reduce the level of oxygen in the boiler by 18%, as you see on the bottom line here. And when you reduce the level of oxygen in the boiler, you will find that the emission of nitrous monoxide was reduced by 25%, nitrous dioxide was reduced by 88%, sulfur dioxide was reduced by 34%, and hydrocyanuric acid was reduced by 85%. This improvement will continue for 3 weeks before the boiler will stabilize on a new level. At this trial, we also saw that the sedimentation was reduced by 23%, and the calorific content in the bottom ash was reduced up to 62%. We asked the University of Rotterdam, which performed this trial, to study carbon monoxide, sulfur dioxide, and NOx. But in their final report to us, they also comment that the emission of formaldehyde, acetone, hydrocyanuric acid, and hydrochloric acid reduced significantly and was close to zero. Summary of the performance from our combustion catalyst. We reduce the creation of carbon monoxide and increase the creation of carbon dioxide, which will increase the heat release. We reduce sedimentation on the heat exchanger, which then will increase the heat transfer. Both of these items will increase fuel efficiency. It will also reduce the level of oxygen in the boiler, which then again will reduce the creation of NOx. It will reduce the creation of sulfur dioxide and reduce the creation of particle matter. In and this will improve the emission from your boiler. In addition, the reduced creation of sulfur dioxide and reduced creation of hydrocyanuric acid will reduce the corrosion in your boiler. Thank you for listening to me. If you have any questions, please contact myself or J.K. Sharma in Delhi. Thank you.
Thank you, Leif, for the wonderful recorded presentation, and glad that we have your presence for the session as well, because we have received few questions, but we'll be taking those questions right after the presentations, so that we can accommodate all the possible questions we are going to get. Moving on, I will request Mr. Gladstone Evans and then Dr. Ila Tiwari for the presentation. So over to you, Mr. Evans, and then I will request Dr. Tiwari to present right after Mr. Evans, so that we can start taking the questions.
Okay, thank you. Yeah, good evening to all. So I'm from AvanteGarde Engineers and Consultants, heading the thermal department of AvanteGarde, and I'm going to share our experience with respect to waste to energy, mainly concentrating on the incineration technology. So before going into the detailed presentation part, I would like to introduce about our company for about 5 minutes. So from AvanteGarde, we have 3 sub-companies. One is AvanteGarde Engineers and Consultants Private Limited and AvanteGarde Systems and Controls Private Limited. Both are with both these plants, we do all the consultancy and engineering services for our Indian projects. And we have one AvanteGarde Engineers and Consultants Sharjah, where we do all our overseas projects. And we have started in the year 1990, and now we are in 2020. We have completed almost 30 years of our engineering services. Then we have our 4 founder directors. They had a very wide experience in BHEL. They were working there for about 15 to 20 years, and they have started our company. And we have wide experience, especially with respect to the boilers, power plants, and waste to energy systems. And all our directors have achieved the Lifetime Achievement Award, and especially Mr. Ragothaman, he has got the Lifetime Achievement Award in the waste to energy for the waste to energy works. Then we are ISO 9001-2015 company, and we are accredited by the Consultancy Development Center. And we are one of the only consultants in India. We have the S stamp, and we have around 200 plus professionals in various disciplines to handle most of the process plants and power plants. Then we have carried more than 2000 plus projects with 500 clients. So most of our projects are repeat projects. And we have done projects for about more than 40 countries across the world. And our main area of business is consultancy of the power plant, either in the terms of cogeneration or CPP, IPP, or biomass based power plant, or municipal solid waste power plant, waste heat recovery, or gas engine exhaust type of power plants. Any type of power plant, we are involved in that. And we also design boilers, because all our directors are from ex-BHEL. They have very well experience in boiler design. So we also design boilers and we give to the companies who doesn't have the in-house boiler design capability. Mainly grade fed boilers, atmospheric fluid-based bed boilers, and waste to energy boilers, then waste heat recovery boilers, and vinasse-fired boilers, which is the effluent from the distillery plants, which is critical, very highly polluted effluent which comes out of the distillery plant, where we have a technology to efficiently dispose that waste. Next, we also supply certain critical components in the boilers. And apart from that, we do a lot of sugar plant process consultancy for the sugar plants, consultancy for bio-CNG plants, consultancy for distillery and ethanol plants, and consultancy for wastewater treatment and electricity plants. And also we have done a lot of solar PV based power plants and solar thermal power plants as well. And we have our part of our experience I have listed here. Mainly we have commissioned almost around 6,700 megawatt of cumulative projects. Then almost 3,000 megawatt of power projects are under various stages of execution, putting to almost 9,000 megawatt of cumulative power we are doing it, or we have done it. Then coming to the municipal solid waste power plant, we have commissioned 3 projects of cumulative capacity 57 megawatt, and 5 projects are under various stages of implementation with a cumulative capacity of 107 megawatt. And distillery based plants, we have done almost 20 projects. And specific to the municipal solid waste power plants, the first plant we have done in 2007, which is around 6 megawatt RDF based power plant, which is commissioned in Vijayawada. The plant was in operation for about 3 to 4 years, and due to the technical limitation in the RDF preparation, the plant was under shutdown. Then after that, in 2016, we have done 24 megawatt municipal solid waste based power plant with direct mass incineration route. With not RDF, it's a direct firing of municipal solid waste. Almost burning 1,200 TPD, tons per day of waste. And the boiler and the power plant is in operation from 2016 onwards. Then recently we have commissioned Hyderabad MSW based project, which is around 27 megawatt, same direct mass incineration based waste to energy plant, firing 1,200 TPD, and it is commissioned from this year August 2020, and it is in operation as of now. So in 2020, as of now, we have commissioned around 57 megawatt, and with the available projects in hand, in 2022, we will be commissioning totally 160 megawatt of power. And many other projects, many other clients are right now in touch with us, and we expect this 164 megawatt to go up further. So now coming to the incineration topic. So prediction as per Indian scenario is there is 62 million tons per annum of MSW is available. Out of it goes out to 1.7 lakhs ton per day of MSW, out of which 90% of the waste is being collected, and remaining 10% it remains as uncollected waste. From the collected waste of 20% of the waste is now being processed, either in terms of composting or maybe biogas generation or incineration route. Almost 20% of the waste is being processed, and remaining 80% of the waste is dumped in the open dump yard, creating a pollution hazard. So if you come on the power generation potential, almost we have a potential with the available MSW, we have a potential of around an average power of around 2000 megawatt, whereas the present power generation from MSW is only 60 megawatt. Then other waste like e-waste, biomedical waste and hazardous waste, these should not be combined with municipal solid waste. These have to be handled it separately. Added to that, the construction waste also should be handled it separately. So the various conversion technologies available today can be broadly classified into two. One is biological process technology, and next is the thermal conversion technology. The biological processing composed of composting, biomethanation, etc. And the thermal route, it is incineration, gasification, pyrolysis, and pelletization. These are the various technologies available. This incineration handles the mixed waste. It can be a dry waste, wet waste, whatever waste is available. It is the incineration can handle. Whereas gasification and pyrolysis requires a certain pre-treatment before letting it into this system. And pelletization also requires a pre-treatment to produce RDF in terms of pellets, fluff, or maybe in various other forms. So, out of these various technologies available, how to select a technology? We have to analyze the following steps. One, the system, the technology what you select should be flexible enough to handle the wide change in the MSW quality. So here, this is the one of the major, constraint in the MSW based energy generation system, because unlike any other power plants, like if you take coal, the properties are almost fixed depending on the mines or depending on various imported fuel. The properties of the fuels are fixed. Similarly, when you take about biomass, whether it is a bagasse, rice husk, or any other agricultural residue, the properties of the residues are more or less fixed. But when you come to the MSW, there is a wide range of quality ranging from 800 kilocal per kg up to around 4,000, 5,000 kilocal per kg. So when you take a fuel from a marketplace, its calorific value is different. When you take the fuel from the industrial place, its calorific value is different. So there is a big, depending on your seasonal variation, your location variation, your country variation. So many variations are available in the MSW, which makes the system a real challenge. So the technology what you select should be flexible enough to handle the wide variation in the MSW qualities. Second, the technology what you select should be of proven technology, and it should be available in-house. Within India, if the technology is available, it will be better, and it should be well proven. Then experience in operation and maintenance. Once you install a technology, or when you erect an equipment, there should be required operation and maintenance expertise should be available within the country. Then meeting the environmental and pollution norms. So you have to meet the pollution norms. Then you have to meet the contractual targets, and also energy recovery and overall economics. So the technology what you select should take care of all these aspects. So analyzing all these things with the present available technology for a commercial production, incineration is one of the best technology available. So incineration is nothing but it's a burning of the fuel in a controlled atmosphere in presence of oxygen. So in the incineration technology is divided into two. One is burning the fuel on as received basis, and second, burning the fuel with pre-treated waste by means of pre-treatment. So you go through a set of various treatment process, and then finally you take the fuel to the boiler, which you call it as RDF. And RDF also, we have so many varieties of RDF. RDF, if you see the ASME classification, you have RDF 1 up to around 7, 8 classifications are available. So burning of as received waste require a little or no pre-treatment. So this technology, what we call as a direct mass incineration, which we have followed in all of our projects, which requires no pre-treatment or a very little pre-treatment. So the advantages of the incineration plants, there are almost so many various advantages. I have listed few of them. One, it addresses 3 types of environmental issue in one stroke. One, pollution due to open dumping, then effective land use, then environmental impact because of the fossil power plants. So, depending on the power generation from the MSW based power plants, to that extent, you can reduce the power from the, we can reduce the fossil fuels. Thereby, you can reduce the environmental impact. Second, there is a volume reduction to an extent of 85 to 90% of the MSW. See, when you burn the MSW in the boilers, some amount of ash is being which comes as a byproduct. This ash has to be disposed. So when you compare the volume of the MSW versus the byproduct which comes out, it is around 90%. There will be only 10% left out, which has to be disposed. The disposable various options will be covered in the further slides. Then third is a waste reduction and destruction is immediate. It is not a long wait is not required. Once you collect the fuel, MSW from various places, you directly dump in the in front of the boiler, and then immediately you put it in the boiler and you produce power. So your waste to the destruction is immediate. You need not have a long wait. Then no foul smell and infection to the public. Then incineration is carried out at generation site. Then gas discharge can be well controlled to the permissible norms by following an extensive gas treatment system. Then ash, which comes as a residue, is a sterile in nature, which doesn't protrude. So the investment the investment is quite high, but that can be offset by the heat recovery and the sale of energy. Then there are various incineration technology. One is a moving grate, then fluid-based bed boiler technology, and rotary kiln. This moving grate technology is normally used for either pre-treated waste, or it can be used for a mixed waste, or which is directly dumped into the in front of the boiler. Whereas fluid-based bed boiler cannot be used if it is a direct fuel. It is difficult to use. So when you go for a fluid-based bed boiler, then necessary pre-treatment is mandatory. So normally this fluid-based bed boilers are used for a highly pre-treated RDF, and for a co-firing application, these boilers are used. Then rotary kiln are normally used for hazardous waste, hospital waste, and industrial waste. For all those things, this rotary kiln technology is used. So we will be concentrating on the grate-fired technology. So this is a typical arrangement of a boiler. Waste to energy power plant, where you have various systems in that. One, MSW handling and pre-processing and feeding system. So this is 1, 2, 3, 4. This part comes under the MSW handling, processing, and feeding system. Next is the incineration system, that is burning in the boiler. That is the incineration system. Then heat recovery system, that is from the fuel. The chemical energy from the fuel is converted into thermal energy, and the thermal energy is converted into electrical, which is the heat recovery system. Next is a flue gas cleaning system. So once the flue gas comes out of the boiler, it has to be cleaned to an acceptable level listed by the Pollution Control Board. Then you have ash collection and handling and storage and disposal system, and you have the leachate collection and disposal system. These are the various systems available in the waste to energy power plant, incineration based waste to energy power plant. So these are some photos. The truck which carries the MSW is directly comes into the plant, and there is a pit. The fuel, the MSW is directly dumped into the pit, and there are control systems by the means of a crane, you have to take it and put it into the boiler. So this is the cross-section view of a typical waste to energy boiler which we have installed in one of the projects. So this is you have the first the tipping floor area, and this is a pit. So here in this incineration plant, the pit plays a major role, which acts as a pre-treatment system. I will explain in further slides. So there will be two grab cranes installed in that. One grab crane has an exclusive function of shuffling the fuel in the pit, and by another grab, you take the fuel from the pit and put it into the boiler for further process. So functions of the pit. So pit forms a very important vital role in the overall performance of the whole system. One, to reduce the surface moisture, because depending on the season, if whether it's a rainy season or in any other season, the moisture in the fuel will be high. For example, when you take the waste from the marketplace, from vegetable markets, fruit markets, flower markets, the moisture will be very high. So directly you cannot fire that high moisture into the boiler. So you store the MSW into the pit for about 5 to 10 days, so that because of that head, the fuel head, the fuel will get compressed and the leachate comes out of the system and it gets collected. So depending on the number of days storage and depending on the storage head and volume, there is a possibility of leachate collection to an extent of 5 to 20%. So one purpose is to reduce the surface moisture. Second, to homogenize the incoming fuel, because since the MSW you get from various places with the varying calorific value or varying nature, when you put it in the pit for about 5 to 10 days, and when you keep on shuffling it, the more or less the calorific value of the fuel will be more or less same. So thereby it gives a better burning characteristics in the boiler without any major load fluctuations. Then removal of large debris by means of shuffling. If you find any large wooden logs or maybe particles, it comes out from by the grab, and there are separate chute available where you put it through the chute and it comes to a shredder arrangement where you shred it and then take it back to the pit again. Then to increase the heating value of the fuel, as I explained, because of the reduction in moisture, that leachate collection, making homogeneous mixture and removing of large debris and inerts, the calorific value of the fuel will get increased. And also it creates a buffer to reduce the fluctuation in the boiler. So with these activities in the pit, the MSW from the pit classifies under RDF 1 and 2 classifications, because you are reducing the moisture, you are more or less you are making the fuel homogeneous, and you are removing the inerts, large inerts and large size particles. And by doing all these things, this is qualified as an RDF under ASTM 1 and 2 classifications. Then this is the increase in, for example, if your incoming calorific value is 1100, you are by storing up to 20% of moisture reduction is possible depending on the season and depending on the storage days. If you are able to reduce 5% moisture, the calorific value increases from 1100 to 1180. That is around 80 kilocalorie increase is there. And when you reduce to 10%, further increase from 1100 to 1258. Similarly, when the moisture reduces by 20%, your calorific value increase to 1416 kilocal per kg. So this is a graph which shows the leachate collection or the moisture reduction versus increase in calorific value. By increasing the calorific value, the boiler efficiency also increases. For example, from 1100 calorific value is 75.5, it gets increased to 78.3 by the pit. So the usefulness of the pit is very essential or plays a vital role in the incineration based power plants. So the after storing for about 5 to 10 days, you take the fuel and then put it in by means of a grab. You put it into the chute, and by the ram feeder, this is one, you push it to the grate. And by supplying air, you burn the fuel is burnt, and you convert water into steam. Then therefore the water is converted into steam. And here, if you see this, the air required for the combustion, we take it from the pit. Thereby, you maintain a slightly negative pressure in the pit so that whatever smell doesn't go out of the system. So even when you stand near the pit, in front of the pit, you will not have any smell outside because you are maintaining a negative pressure, and that air you are taking it and putting it into the boiler. So you will not find any smell outside the system. So one of the major advantages when compared to the other system is that you store the fuel in the pit. From the pit you take the air and maintain a negative pressure in the pit so that no smell goes outside. All the smell by means of the fan, you take it and then put it into the boiler. So this is about, so you just put it in the boiler and fire the system, fire the MSW, and the water is converted into steam, and steam by passing it to the turbine, you produce power. So this once the water is converted into steam, it is a conventional power cycle which we normally follow in all the power plants. And when you see the history of the steam cycle, higher the pressure and higher the temperature, more is the power generation, which is true in case of this municipal solid waste fad also. But there is another disadvantage in doing so. But normally, because of the characteristics of the fuel, we are forced to operate the waste to energy plant. We are forced to design the waste to energy plant with 45 ATA and 400 degrees centigrade. But now there are technologies available to even go to our standard pressure level of 110 and 540 degrees by going for a very expensive material, superheater material, but which is currently, getting in India is difficult. Maybe in future, in days to come, the same technology will be available in India also. But currently, based on the in-house technology available, people go with the 45 ATA and 400 degrees centigrade. So the selection of the boiler parameter depends on the capacity of the power generation unit. Maybe whether it is depending on the power plant capacity, 5 megawatt, 10 megawatt, or 50 megawatt, 100 megawatt. Depending on that, the cycle parameter varies. Then depending on the type of power plant under considerations, then general characteristics of fuel and ash, the pressure selection is changes. Then when you want to operate the power plant with the existing unit, then we may, for a better flexibility, we may go with the existing plant pressure and temperature. Then initial investment and cost economics and limitation in the technology followed. So based on the characteristics of the fuel, the initial investment and cost economics, and the limitation of the technology followed. Because of these three reasons, we are limited to 45 ATA and 400 degrees centigrade. So coming to the characteristics of municipal solid waste, I have given a comparison, the characteristics of Indian coal, characteristics of biomass fuel like rice husk and bagasse versus the characteristics of municipal solid waste. If you see that one-to-one comparison, which I have marked in red, the sodium oxide, potassium oxide, SO3, and Cl, chlorine, and initial deformation temperature. There is a lot of difference between other conventional fuels and the municipal solid waste. So these parameters limit the pressure and temperature to 42 atta and 400 degrees centigrade. When you go for higher pressure and temperature, then you will have problems like corrosion, slagging, fouling. All those problems will be there, will happen in the boiler. So we are with the current situations, we are limited to 45 atta and 400 degrees centigrade. So this is a typical heat and mass balance diagram which we are executing for a 750 TPD waste to energy plant. So these are the emission standard solid waste management rules 2016. So for the first column is the limitation as per our Indian rules. Particulate emission is 50, NOx 400, SOx 200, HCl 50. So these are the current norms. Whereas the international norms is 10, NOx is 200, SOx is 50, HCl 10. And very soon, in India also, they are going to revise the rules similar to the international standards. So to achieve the pollution norms as stated in Solid Waste Management Rule 2016, we have to go for an extensive gas cleaning and disposal system. So since you are burning the as received waste, there are a lot of plastics involved in that, and there is dioxins involved in the system. There is a high temperature dioxin and you have low temperature dioxins. Then you have NOx in the system, you have HCl, SOx, heavy metals and dust. These are the various pollutant which is present in the flue gas. So to reduce the high temperature dioxins, the solid waste management rule talks about a furnace temperature of 900 degrees centigrade, not less than for about 2 seconds. This you have to maintain into the furnace so that the disintegration of NOx takes place. Then high temperature NOx you can avoid by using this. Then NOx you can follow, you go for a SCR and SNCR system to control the NOx. Then HCl and SOx can be controlled by going for a flue gas reactor system. It can be wet, dry or semi-dry. Various types of system is available to depending on the characteristics of the fuel. Next, heavy metals. You have activated carbon injection system. This will take care of the heavy metals and also it takes care of the low temperature dioxins present in the system. And to limit the dust pollution, we have the back filter installed in the system. Then this system which we have followed in all of our plants, that is semi-dry system, where you have the limestone. The limestone is mixed with the mixed with the water, and it is made as a slurry, and it is sprayed in a spray absorber, where it gets contact with the flue gas and it gets reacted, and you get the reasonably clean gas as per the pollution norms, and then further it is treated in the back filter and your outlet norms will be maintained as per the pollution requirements. And the chimney height will be around 50 to 60 meters depending on the incoming fuel properties. Then ash, you have bottom ash generation and you have intermittent the heat transfer surface. There is some downstream on the back filter you have ash collection. So the ash collection which you collected in the grate will be a coarse ash, and which we collect in the back filter will be a very fine ash, and in below the heat transfer surface it will be a combination of fine and coarse ash. So these ash can be disposed one to in the construction fill area or low lane area. For the filling of the landfill it is used, Then for road construction, they are using it. Then pavement blocks, non-load bearing pavement block preparation, people are using it. Then for landfill cover, they will use it, and some percentage is mixed in the cement block production. So these are the various usage of the ash residue. Then another major part is the leachate collection. So depending on the, whether it's a dry season, rainy season, or various climatic condition, the collection of the leachate varies from 5% to almost 20%. So that leachate is collected and you take it into a leachate pond, and further treatment of the leachate is being carried out. So even by RO, there are so many type of leachate treatment available. One is RO based system, and second is a biological treatment followed by RO system. In this, some amount of power can be produced. That is, it is estimated as 50 kilowatt per meter cube per hour leachate. Per meter cube per hour of leachate, around 15 kilowatt of power can be produced. So various waste to energy configuration. You have 1 boiler 1 TG configuration. You have 2 boiler 2 TG 1 TG configuration, 3 boiler 1 TG, and 2 boilers 2 TG configuration. So all depends on flexibility and cost. So if you go for a plant less than 850 TPD, we can go for 1 boiler and 1 TG configuration. So for one of a plant in Pune for 750, we are going for 1 boiler 1 TG configuration. For above 850 in the plant at Delhi and Hyderabad, we go for 2 boiler and 1 TG configuration. Then in the plant at Jintal, they went for 3 boiler and 1 TG configuration. Then if your economics and cost works out, even we can go for 2 boiler and 2 TG configuration. So considering our Indian conditions and economics and everything, 1 boiler and 1 TG and 2 boiler 1 TG configuration are widely followed in the Indian industry. So typically a 300 TPD plant, depending on the calorific value and seasonal variation, you can produce power from the extent of 4 to 6 megawatt. From 450 TPD, you can get around 6 to 8 megawatt. And from 600 TPD, you can generate 8 to 12 megawatt. And from 750 TPD, you can generate from 10 to 14 megawatt. See here, even though, the average generation will be around 5 megawatt, but when you size the plant, you have to size it for the higher generation, because these plants have to be operated for almost more than 25 or 30 years. In year by year, there are some discipline followed in various municipalities, like source level segregation, and so many things are being tried out. Even though we are not 100% successful now, in years to come, definitely we will achieve in that. So at that particular time also, you should be able to handle the MSW. So the system has to be designed for the maximum capacity. So these are the log sheet from the operating plants. In Delhi plant, you can even, this data is available on the online. This data I have taken yesterday night. At that time, it was operating at 18 megawatt. Similarly, Jindal Okla was operating around 19 megawatt. And the Hyderabad waste energy plant was operating around 20 megawatt. So these are the various operating log sheets from the existing plants. So this is one of the largest waste energy plant in the world. One is in the China, which handles 5,000 TPD of waste with a capacity of around with a power output of 168 megawatt, which is under implementation. Similarly, in Dubai, there is one 5,500 TPD waste to energy plant generating 185 megawatt of power, which is under implementation. And these plants at various countries, they even locate at the heart of the city. If you see, this is a city where the waste to energy plant is located at the heart of the plant city. Similarly, here also it's like that. So these are some of the photo of the installations worldwide. So this plant is the plant which we have done for Delhi, the Ramki Enviro. For them, we are the consultant. This is a 24 megawatt waste to energy plant burning 1200 TPD of waste. This is another plant which I think it's a Jabalpur plant. So as a summary, so this is one of a new beginning for a very old source. So this direct mass incineration with the energy recovery is one of the best waste to energy technology suitable for wide varying fuel like MSW for effective disposal of waste. There are more than 1,000 waste to energy plant with this technology operating worldwide in India. Worldwide. In India, around, I think this is a bit old slide, around more than 5 plants are in successful operation and few plants are under construction stage. In the incineration technology, there is a volume reduction to an extent of 90% and gases are let out from the chimney satisfying the pollution norms. Most of the ash from the waste to energy plant can be used. Then there is a power generation potential from the waste to MSW in the order of 270 to 445 kilowatt per ton per hour of MSW depending on the lower calorific value of the MSW. So with the tipping fees and with the capital subsidy from the government in terms of viability gap fund and export power cost of around 7 rupees per unit, the direct mass incineration waste to energy plant becomes viable and the payback is less than 5 years. If the subsidy is not available from the government, maybe the unit cost can be slightly increased, and with higher tipping fees, again the payback can be less than 5 years, and the plants are very much viable in the Indian scenario. So thank you.
Thank you, Mr. Evans, for the presentation and for taking us through the different methods and different technologies that AvanteGarde is providing and being there in the industry for for close to 30 years. Moving on to the last presentation, I would request Dr. Ila Tiwari to start the presentation, and then we will move towards the Q&A session for the last session.
Right. So, good evening, dignitaries, organizers, and my dear friends. Quickly, I introduce myself. I'm Dr. Ila Tiwari, working with SMS Envocare in solid waste vertical and looking after all the statutory, legal, and the technical compliances for solid waste management projects across India. I'm extremely glad to be here with all of you. And first of all, I would like to thank the speakers, Mr. Ivan, Mr. Harshit, Mr. Leif, for their very informative presentation and detailed insight of their products and the projects across country. So let's get started. So development of waste to energy projects and the technologies in India. In this, I'll be sharing some information on technologies which are available in India for waste to energy, the opportunities and the challenges associated with these technologies.
We lost Dr. Tiwari's connection because of the internet connectivity, and till the time we have her back on stage with us, we have a question for Mr. Evans that Mr. Karthik is asking, who's a manager customer application from Valmet Technologies Private Limited, that what is the turn down of the incineration boilers?
See, the turn down will be around 60 to 100%, 60%.
And there's a follow-up question from him, is that what are the availability percentage for the incineration plants?
See, based on our experience, the first plant, the first year, the availability was around 70%. But now, from the second year also, it has slightly improved to 75 to 80%. Right now, it is operating at around 85 to 90%.
Wonderful.
For commercial reasons, we can take around 85% from second year onwards.
Absolutely. Okay, I hope that answers Mr. Karthik's question. And next is from Mr. Pankaj Yadav from Reliance Industries for Mr. Leif. That what is the composition of feed? Do we have a commercial process where we have used this complex?
The waste to energy I showed at the presentation is a normal European municipal waste. Slightly higher calorific value than the waste in India. Due to the COVID-19, everything has stopped now, but we are starting up again with a waste to energy power plant in Poland in January. So if you ask me again in a couple of weeks, we will have a normal waste to energy power plant running with using our chemicals.
That's wonderful. That's wonderful, and I guess that answers his question. In the meanwhile, we have a question from Mr. Prabhat Verma. I would invite him on stage to ask the question.
My question is to J. Gladstone Evans.
Sure.
I hope he's there.
Yeah,
yes, absolutely, he's there.
Okay. AvanteGarde is one of the old consultant and very reputed and renowned one. My question to him is in two parts. One is whatever we talk here in terms of waste to energy, we always give reference of plants which are in Norway, Denmark, basically European countries. And those plants look like 5-star hotel and it is within the community and we feel good about it. It's a good technology. But we must know the difference of the waste. The kind of waste which is produced in Europe and the kind of waste we produce here in India is entirely different. And that is why we have seen projects failing. Many projects, a lot of money has been spent. It ran for 2 years and then later on we declared it was the wrong technology we selected. So the first question to Gladstone, being a consultant, and I wish the consultant becomes R&D organization also, because there are many technologies which is not prevailing in the world because it is not required in third world. So for India, we have to have a technology which is suitable for our waste. So my question is there any technology which is suitable for Indian waste, which runs for long number of years, 20, 25 years? Or we will have the same in every plant, which will run for few years, because we have seen heap of garbage all around Delhi and other places. So that is question number one. If you answer question number two, then I'll ask answer question number one, then I will ask question number two also.
Yeah, okay. See, this, as you told, you are right. See, we cannot compare our plans with respect to the plans in Europe or Western countries like that. But more or less...
we are working on their technology, unfortunately.
Yeah, and see, see, what we can more or less compare the technology, what are the waste, what is generated in China, maybe a few years back, is similar to what we have right now in India. See, the thing is, for the first plant, when we took the boilers from China, see, we had a lot of problems in terms of, because they designed the boiler based on their characteristic and their fuel, their nature of everything they have considered and they have done it. We would have to do a lot of modifications in the first unit, right from the fuel flow chute. So they have given some arrangement, then we have to slightly modify to take care of the Indian conditions. And when we discussed with the China people, they were telling, no, because we thought your fuel is like our fuel and we have done based on that. So for this type of fuel, you have to do some modifications and so many things we have done for the first project. And then slowly, that's what I told, the availability of the first time was very low, and somehow one by one we tried to attack everything. And then in the other project which has been commissioned in the August 2020, for a surprise, till now, after the boiler commissioned, not even a single shutdown, nothing. Whatever experience we had in the first plant, we have taken care in the second unit with the same customer, and now right from the day one, it is almost operating at the full load. Thing is, as you told, okay, when you take the technology from the abroad as such, definitely there are problems, and we have to tailor make certain problems we have to study and then modify to suit our Indian conditions. Now, since we have that experience, we pass on that experience for our other further projects, so that we can such problems will be avoided in the projects. That is one. Second, see, in abroad, because of maybe their way of spending, or maybe government is giving so many subsidies or something like that, they can maintain the plant as a 5-star hotel or something like that. But in Indian conditions, a private company, he has to, get a profit out of it, considering so many conditions. Such type of, cleanliness and everything is very difficult to adopt here. But to some extent, if you see the Delhi plant and more towards our Hyderabad plant, they are reasonably good. But one thing is, the main problem, main advantage, if I say, if you go even near the pit, you will not feel the smell. And most of the things we are taken care, and we are slowly trying to adopt a system, a hi-fi system similar to the Western countries, but we are not achieved to that level. But nevertheless, it is we are improving in that aspect.
Thank you, Mr. Evans, and I would like to welcome Mr. Ashwin Kumar Khatriji, Director General from Mission Energy Foundation.
Thanks, Akshay, for giving me the mic once again. I think we are done with the slides and done with the questions, Akshay.
Yeah.
Yeah. So we move further. We almost 18 hours, 30 minutes, half past 18 hours now. We begin our sessions around 9 o'clock in the morning, though my day begins around 8 in the morning. So I think most of the participants also might have got exhausted, unlike me. So, but we still have the energies to capture on the opportunity to meet people at our networking launch, which will be open the whole night. The networking launch and arenas are open for people to network with each other, talk to each other, as we are not able to meet people in the pandemic times. But this opportunity, which is right now available with us to network and talk to us, I hope everybody enjoys and take the leverages about it. With this, I would like to thank all the participants who have curiously listened to all the important dignitaries and speakers who have burnt their oil in the night. Many speakers who are from the international as well, who are there in the different time zones, have taken time to participate in the in our Indian Standard Time. With this, I believe the eruption of MSW and biomass will shortly happen to generate clean fuel and support the Indian economy. Thank you all. I once again wish and say that tomorrow we start the session by 10 o'clock, and I request all the participants to join 30 minutes prior to the schedule. Thank you. Thank you all. Have a nice night. Be safe. Be home. Be at home. Do not go out of your home. Thank you. Good night.